Okay, the combined gas law. For this problem, when I read it, obviously right here at the top, I am telling you it's a combined gas law problem, but you won't always get that on the test or on the quiz. I'm not always going to tell you which gas law it is, so I'm going to show you a way to figure out which gas law you're using and then which equation you'll have to use. As I read the problem, I'm going to go ahead and box in my variables and just kind of quickly identify them. So it says at 15 degrees Celsius, I can box that in and identify that quickly as my temperature 1. And then 3 atmospheres, I can identify that quickly as my pressure 2. And that last variable in the first sentence, I can quickly label that as volume 1. Now, how did I know that 15 was my temperature, 3 was my pressure, and 50 was my volume? It's all about your units, ladies and gentlemen. You have to look at these units. We know that atmospheres relates to pressure, we know that Celsius relates to temperature, and we know that milliliters relates to volume. So that's how I knew which variable was which. Okay, then it says the temperature is going to increase, so I can box this in and quickly label that as my second temperature. And then it's going to be transferred into a new volume of a container. There's my volume 2. What will be the new pressure? We are asked to find P2. So I'm going to put a big green question mark by that one. That's my unknown. So when I look at these variables that I just quickly labeled here, I see pressure, I see volume, temperature, pressure, volume, temperature. I see all 3 variables. Whenever you see all 3 variables, you know you're going to have to use the combined gas law. So I'm going to write it off to the side. P1 V1 over T1 equals P2 V2 over T2. There we go. From here, it's basically just a plug and chug situation. For pressure 1, I'm going to go ahead and plug in 3 atmospheres. Volume 1 we said was 50 milliliters. And temperature, please don't make my favorite mistake. This is my favorite mistake. So a lot of students like to plug in degrees Celsius down here in their gas laws. If you did that, please put a big fat X through that. Cross that off. You cannot use degrees Celsius. You have to convert to Kelvin. It's a real simple conversion. All you do is add 273. Won't take you very long. P2 is my unknown. 20 milliliters is my volume 2. And then again, don't make the same mistake. If you put 50 degrees Celsius down here, please cross it out with a big fat X. That is not correct. You have to use Kelvin. So it's a simple conversion. Add 273. So I'm going to put 323 Kelvin down below. Perfect. Now, how do I solve it? It looks very scary. I understand. Here is your unknown. It's up top. We want to get that one all on its own. To get my variable isolated, I'm going to cross multiply wherever I see the 3 across from one another. For me, it just helps to circle them in. Okay, so I know that there's 3 variables here. I just circled them in. Those are the 3 that I'm going to multiply. So punch in your calculator 3 times 50 times 323. And you're going to divide by the remaining 2 numbers. So I'll put a little division symbol by these remaining 2 numbers here. So after you multiply those 3, you're going to divide by 288, hit divide again, you're going to divide by 20, and you should get a final answer. P2 should be about 8.4, I'm not sure if I rounded there, atmospheres for your unit. Okay, so again, how did I solve that? Cross multiply and then divide by the remaining 2 numbers. The 3 that are circled in green, you multiply, then hit divide by 288 and divide by 20. This has been a Rodriguez original production of the combined gas law. I hope you enjoyed it. Watch it again if you need to.